Thanks very much. Can everybody hear me okay at the back? All right, awesome, lovely. So my name is Ivan Towlson. I work for Green Button. We are a small Wellington-based company who produce a platform for shifting high-performance workloads like animation, scientific computing, financial computing up into the cloud. I'm not going to be talking about the cloud or high-performance computing today. I'm going to talk about something far scarier, type systems. And I've had a lot of people asking me over the course of the day, so type systems, what do you mean by that? Is that like static versus dynamic? Well, that's part of it. By type system, I'm talking about the way that languages encourage us to think about values, how they encourage us to represent values, and what those ways of representation can do for us. And despite the great divide between the static and dynamic camps, there's actually a lot of commonality in the way that most of the mainstream languages nowadays think about type systems. If you think about something like Python or Ruby or CSharp or Java or C++ or JavaScript, there's a lot of ways in which they represent, they have the same kind of ideas about types. In most of them, for example, things are represented by classes. That's pretty much you've got primitives and you've got classes, and that's about the only way you've got of defining types. You've got things like nulls flying around. You know, in Java, any class has got a null value. Similarly, in C#, most types have got null values. And what I want to do in this talk is to maybe encourage you to think about some of the, or encourage you to look outside that sort of consensus type system. And the reason that I think it's worth doing that is because the consensus type system isn't all it could be. It gets the job done, but it's not everything we might like. It's weak in terms of the safety guarantees it gives you. You can't be sure that you're doing things right. You're not getting as much help as you could from the compiler. The type system is adequate, but it doesn't help. Most type systems nowadays encourage you, they require you to write quite a lot of code that the compiler ought to be able to figure out for itself. They're not helping you. A lot of the time, you're having to write boilerplate code, whereas if you had some sort of more clever mechanism, you might be able to get rid of that boilerplate and push that away into the type system. The type system is not helping you. It's forcing you to do extra work. And even that great divide between static and dynamic, between the Python and Ruby worlds, where you can go crazy, you can pass anything to anything else, and you can add properties and remove methods, and it's all jolly exciting, and things might work or they might not, versus the ever so strict world of C# or Java, where the compiler is going to force you to prove everything before you do it. This is not a useful divide. It does not help. It is not making your work easier. It's forcing you to choose, go all in one way or the other. And I don't think that's a useful way to think about things. So I want to kick off with a demonstration of the difference between two type systems. In this case, I'm going to use the C# language, which is similar to Java, for those of you who are not familiar with it, and the FSharp language, which is an open source functional language from Microsoft. It's got some similarities to Haskell, and in fact, you're going to see, if you were here for Katie's talk, you're going to see a lot of similarities between what I'm about to show you now and the Haskell type system. So let's take a very simple use case where I've got some sort of data source, some sort of collection of users, and I want to look up a user by ID. So I'm going to write a find function in C#, and I'm going to use the standard idiom of if I don't find something, if I don't find a matching user, I'm going to return null. Life is good. Everyone's familiar with that pattern. We've all seen it a lot of times. And as long as that returns a user, I can do things with that user, and life is good. Everybody is happy. Problem comes when that function fails and returns null. In that case, I'm going to blithely continue on. I'm going to take the name of that user, and I'm going to crash with a null reference exception. And That's annoying to me because, well, firstly, it could have been prevented if I'd had some sort of warning that the user might not be there. And secondly, it's going to happen during the demo to the CEO, so that's not ideal. There are some ways you can try to get around that. For example, C uses success codes, so you can kind of have this try-find idiom where it returns a Boolean and an out parameter, and of course, you can just forget to check the Boolean and crash with a null reference exception. Another favored option is, if you don't find anything, throw an exception. Well, great! Now I'd crash with a different exception. Huzzah! All right, so how can we avoid all this? I should have said, yeah, this is not a trivial problem. I know in this example, it looks trivial because we're dealing with a couple of lines of code. It's pretty obvious where the problem is. But if you've got a series of chained things, then it gets very messy. You have to keep putting null checks between all the things. And the error may actually arise somewhere completely different. Tony Hoare, the guy who invented null, he called it his billion-dollar mistake. Current estimates is that he was wrong. It was actually $1 billion a year mistake. The costs of the bugs that come from this one construct are colossal. So what's the alternative? Well, if you're here for Katie's talk, she's already stolen my thunder. You already know what the answer is. But I'm going to show you this in FSharp. So in FSharp, we can define a user type, just as we did in CSharp, very easy. And we can try to write this find function. And you can see I've done it in very much the same way. There's some differences to the implementation. Once again, I'm going to try and return null for the failure case. And when I try and build that, I get an error saying that null is basically saying that null is not a valid value of the user type. And if you're a C# or Java programmer, this seems completely alien. Null is a valid value of any class type. Well, not in FSharp. It's got a different type systems. Types are non-nullable. I cannot return null. I cannot inflict a null reference exception on myself. The compiler will stop me even writing that. So what do I do instead? Well, we saw what I'm going to do from Katie's talk. I can write that try find, but instead of returning a null or whatever, I'm going to return an option, which is FSharp's name for the Haskell maybe. So I've got none, which is the equivalent of nothing, and some, which is the equivalent of just. These are the code words for I didn't get a value, there isn't one, or yes, there is one, and here's what it is. So if I have a look at the signature of try find, if you can see that, it's returning a user option, not a user. And that means that when I call try find and try blithely and ignorantly to take the name of the user that is returned, I get a compiler error because it's saying option hasn't got a name property. User has got a name property, but I haven't got a user yet. I've only got an option. I may be of a user. So how do I get to that user? Well, there are various ways that are provided. Katie showed you the way of doing it using bind, which is kind of the high-level way of doing it and the one that you would actually use in real life. This isn't real life. This is a demo. So I'm going to show you the underlying way, which is pattern matching. So since I've got an option, I can pattern match that on the none case and the some case. And in the none case, well, I haven't got a user, so I can't call name on it. I haven't even got a variable to call .name on, so I'm safe. Life is good. In the some case, the pattern matcher is going to deliver the user into that variable, and now I can call u.name on that with complete safety, complete impunity, because I know I have a user. It cannot be null because user is not nullable. Does that make sense to people? So we've got a different kind of types, and we've got a different approach to how we represent possible failure. It's at the type system level. The compiler can check my working. It's ensured correctness. Now, one of the costs for that, as you can see, is that the compiler insists on me proving things to it. So if I was confident that, yeah, I'm bound to get, this time I'm going to get a user back, this time for sure, I'm bound to get a user rather than a failure, I know this guy's going to be in the collection, then doing all of that checking just feels like a bit, it's verbose, it's unnecessary because I can have confidence in it. And this is one of the things that dynamic languages fans tend to worry about with static languages. They go, well, look, I know that I know what that JSON message looks like. I know it's going to have a .link or a .name property, a .name value in there. I should be able to address that. I shouldn't have to create some sort of class to deserialize into, and the compiler will check that I've typed it all properly, and I'll have to type it several places, and it's all going to be terribly tedious. And in order to get one of the ways, well, the various ways to get around that, the dynamic languages people have a point, and there are a couple of ways to address that. One of them that's been coming in recently is something called gradual typing. The term, as far as I can see, comes from a Python fork where this was implemented, but actually it's more generally applicable, and I'll show you a couple of examples. The idea of gradual typing is that you can mix the dynamic and static modes within one program, even within one file. You can opt into the dynamic mode where you rely only on runtime checking and your intelligence, or you can opt into the static mode where you want that additional safety, where you want to have your work checked. And one example of this that's emerged recently is another Microsoft language called TypeScript. TypeScript is a superset of JavaScript, which means that all valid JavaScript is valid TypeScript. But you can also add safety features to it. So here I've got a web page. This is written 1990s style. Represent! It's 3 text boxes, and oh look, it's an Onclick handler. How long has it been since you saw one of those, eh? My Onclick handler what's that? I got Truck to help me with that one. So here's my Onclick thing. It's very simple. I'm just going to get the name out of one of those text boxes, and I'm going to stuff it into the content of a div. So if I run that up, then I can see, you get to see Internet Explorer as well. How long has it since you've seen Internet Explorer? And that's not actually done quite what we wanted, because, well, as Josh points out, I don't know HTML. I'm a numpty. What is the problem? Well, I'm in TypeScript, so I can actually say, well, look, hang on. I was expecting a string in there. You know, I can't operate a keyboard either, apparently. I was expecting a string in there, like that. You know, I want to be appending strings. Ah, says TypeScript, well, hang on, because I have no guarantee that name is a string. And in fact, looking at that, it turns out the name isn't a string. So I've inadvertently returned the HTML element. If I do that and run that up, then it's correct. So I've been able to opt into a little bit of additional checking. But notice that I can also continue opting out of it. In this case, that dot value, a generic HTML element doesn't necessarily have a dot value property. But in this case, I know that that one will have. So I'm opting into the dynamic mode there. I could go further and put more static checking in there to get rid of those warnings. But I've got the ability to control those knobs, to shift the knobs back and forth and decide how much I want to be dynamic and how much I want to be static. Gradual typing cuts the other way as well. We can also have islands of dynamic or weak typing behavior within a strongly typed program. And I ran into this a couple of days ago when I was playing with our new REST API, which allows us to submit JSON messages rather than ye olde XML. How long has it been since you saw XML? You get all the nostalgia around here. So in C#, the usual way that you'd interact with a service like that is you'd write DTO kind of objects. You'd write classes to represent the message formats, and you'd say, serialize this and deserialize into one of those, and life would be good, and everything would be strongly typed and statically checked. But If you're writing a fairly simple piece of code where you're just sort of doing a web service call, composing a message, and getting back a fairly simple result and extracting a piece of data from that, it may not be worth creating all of those classes. So, for example, to perform a submission to our submit job API, I don't actually need, the web service doesn't care whether I have a class or a dictionary or whatever in my client. All it cares about is the JSON message that arrives, the JSON body of the request. And the JSON serializer, thank you, Mr. Newton King, is perfectly happy to work with a C# anonymous type. So I can just create a type on the fly. The JSON serializer will create an appropriate JSON message from that, send it up to the web service, and it all works. What about on the way back? Well, the deserializer needs something where it can take the JSON message, look at each attribute in that message, and set a property corresponding to that attribute. So what sort of class should I deserialize into? Well, it's got to, looking at the message, it's going to have certain properties like ID and link. Well, I could create a class with those, but then I'm back to having to create classes for everything. How can I have something that can accept whatever properties are going to come back in that JSON message? I can use C#'s dynamic features. There's a class in the .NET base class library called Expando Object, which basically allows you to create new properties on it at runtime. So if I tell the JSON deserializer to read the JSON message into an Expando object, it will just dumbly go through the JSON message, the JSON response body, and create properties like ID and link on the Expando object. And then, thanks to the C# dynamic keyword, I can access those properties in a dynamic way without having to create a class, without having to declare a .link property, just using my awesome beard powers to know that at runtime there will be one, even if the compiler can't prove it. So that's gradual typing from the other side. Does that make sense to people? Can people see what's going on there? Awesome. All right, what if you do want static typing? What if you do want to create classes? Well, at that point, you're kind of in a world of hurt because you have to do some work. You actually have to write code. And we'd rather be goofing off and playing pool. Another of the things that dynamic language advocates find annoying in static languages is just the sheer amount of typing you have to do, the sheer amount of work that you have to do just to tell the compiler what you're doing. When you kind of think, you're a computer. You're meant to be smarter than me. You should be able to work this out for yourself. And we are beginning to see compilers beginning to put in a little bit of effort on our behalf, but it's pretty desultory in most of the mainstream languages. Let's again take a look at C#. And for a while, I've been able to avoid this kind of verbose repetition of type names to save myself writing everything twice by going var. That's nice. That makes life easier. Let's try that on this field. Compiler error. What about this function? Takes the length, does some comparisons, returns a Boolean. You can figure that out, right? I mean, it's clear. That has to return a Boolean. It pretty much has to take an integer. I'm not going to worry about shorts and longs because no one uses shorts and longs. It's a function from integer to Boolean, right? Why do I have to tell the compiler that? Why can't I just write that? Well, computer says no. Let's look at another language randomly chosen from my numerous selection. Oh, it's F# again. So here is the equivalent. Here's that max length again. And if I run that, oh, max length is an integer. How about that? What about is permitted length? Well, that's a little bit more complicated. That's a function. Can the compiler work that out for us? Or am I going to have to put type annotations on there? The F# compiler can look at the body of the function. It can go, well, you're comparing L to an integer. So L must be an integer. And the way that function works is you're doing a couple of comparisons, each of which is going to return a Boolean, because I know what those comparisons do. You're going to AND them together, which takes two Booleans and makes another Boolean. So the output's going to have to be a Boolean. You don't need to tell me anything, Ivan. I'll figure it out for you. I'm your friend. And it just does it. It's much simpler. It's not just simpler. It's also less agonizing. Let's take I would show you this function, but sadly, this screen is not wide enough to encompass it. This is an implementation of the link select many operator. And I've called it collect because collect is a few characters shorter and it's all precious. Look how many times I'm having to specify those generic parameters. T-result, T-source, T-result, T-source, T-source, IEnumerable, T-result. My goodness. Does anybody here have 80 column limits in their source code? Anybody? Yeah, you're not allowed to look at this function. You're not even allowed to look at the signature, I'm afraid. Compare that to the equivalent FSharp code. Now, that's not only able to work out what the signature is, it's able to work out that it's generic in two types, that it's generic in a source type and a result type, and it's going to take in a sequence of the source and a function from source to sequence of result, and it was going to return a sequence of the result. You can see that from the signature. I've not had to write that. The compiler has worked it out. And that's saved me quite a bit of typing. How much typing has it saved me? Well, let's just compare that C# signature to the entire FSharp implementation. It's getting on for twice as long. By choosing a more expressive type system, a more capable compiler, I can actually remove huge amounts of boilerplate typing, boilerplate coding that the compiler can just take away from me. I just think that's a very dramatic difference between those two capabilities. All right, but static typing imposes even more boilerplate on us. If you use something like Ruby on Rails, then you'll know that magic happens. You say, I want to load a collection of penguins from the database, and it goes, have some penguins. They have names, they have ages, they have species. It all just happens by magic. I don't need to create a penguin class if I don't want to. It's all just there using Ruby magic. In C#, I have to write out these. I have to derive a class. No, what is it? I have to create a class, and then I have to implement a data context, and it has a bunch of properties with table of penguin or whatever, and it's all very true. It's a bit different entity frame. Does anyone use entity framework? Right. I'll moderate my language then. Now, you may think, well, we've got code generators for this. You know, I'll put a DBML file in my project. Magic will happen. Life is good. This works OK until you start thinking about things like scripting environments, where you maybe you want to have a little command line script that does some updates to your database or whatever. Well, that's great. My command line script is probably about so long. But then I'm going to need this other file of all my entity definitions traveling along with it. If you have a look at CS script, which script CS, I can't remember, it's the scripting environment for C# that Glenn Block's been working on, you'll run into this kind of problem. Once again, I'd like to compare that with the FSharp solution, which is a mechanism called type providers. Now, type provider is essentially, are there any FSharp people in the room? OK, this is good. Don't tell the FSharp people, but a type provider is basically a code generator, except you don't have to cart around all of that generated code. It all happens behind the scenes. So here's an example of an FSharp script. Now, in FSharp, we don't need a separate scripting tool. The FSI command line is already capable of running scripts in that sort of just-in-time mode. And it's awesome to see C# gaining that capability as well, because a lot of people would like to have that, but are not able to they're not able to devote the time to learning F#. Anyway, in the type providers, there's this thing called the SQL data connection type provider. And I can go, this type is an instance of, I want you to take that type provider and produce me, I want to pass it this connection string. And that's going to give me a strongly typed thing, a strongly typed object, which has got properties on it. And it's going to give me some more types. So it's going to give me that data context type, which you can see has got the types from the various tables in that database. It's quite a small database and quite a specialized one. And that script is now, that's a completely standalone script. I've referenced the type providers assembly. I've said, make me some types from SQL data connection. There's no separate file generated there. So I can prove that to you using my advanced DOS powers. Nothing up my sleeve, as you can see. There is just that script. And if I run FSI type data access, FSI is FSharp interactive, then it's able to spin up the type provider, make instances of those types, and perform a strongly typed database query. So I've got the combination of type safety without having to have all of that additional code hanging around. And you may think, well, okay, that's all right, but realistically, we just drag DBML files on. We come from a Visual Basic background. We just kind of drag things around and hope they work. Any Visual Basic programmers in the room? I don't have to moderate my language. OK. So, but there's other examples where type providers give you a lot more than those kind of traditional sort of GUI code generator things. An example might be if you're working with vectors. So if you've got something like a game engine where you've got to deal with maybe you've got some 2D vectors, you've got some 3D vectors, you've even got some 4D vectors because you're a time travel game or something like that, I don't know. You'll find there's a lot of boilerplate code in there. You're going to have to write the same thing. They're going to have addition, subtraction, you can have things like dot products, that kind of stuff. And they're all basically the same implementation, just got a different number of fields. And you might have different names. You might have, say, a width and height vector and an x and y vector that are used for different purposes. And you want them to be different types. You don't want to be able to add them together or something like that. And again, they're going to be pretty much the same implementation, just you have to, you have to write out the different field names. Well, with F#, you can get rid of that boilerplate by using a vector type provider. So this is this particular one is in the FSharp X project. It's an open source project. You can get it from GitHub. And it's got this vector type provider where you can pass it the names of the fields that you want. And it will give you a vector type with the appropriate number of fields and the appropriate names for those fields. So size 2D and size 3D are types. They are vector types. They're not instances. They are types. So I can create an instance of a size 2D, and you can see I can get IntelliSense on that. I can call methods on that instance. You can see it's got those properties that I gave names for earlier on. And I've got type safety. If I try to add a 2D vector to a 3D vector, then it's not going to let me because add is only defined within a particular vector type. So I've managed to avoid having to write out all of those boilerplate vectors by going to a type provider and saying, you do the work for me. Make me a vector type with these names, with these field names. And it does all of the work for me. A particularly tempting example of this is a regex type provider. Because I can never remember the syntax for accessing regex members. I can never remember the syntax for regex is full stop, but I believe this one works. I'm not going to run it just in case. This is not a good regex for a phone number, obviously, but it serves to demonstrate the purpose. So within a regex, you can have named captures. So here, I've got a phone number with 2 digits, -3 digits, -4 digits, and I've captured those groups into area, district, and number. And that's a perfectly normal .NET regex. What I can do is I can pass that to the regex type provider, and it will now make me a strongly typed object, a strongly typed regex, which I can then use to access those captures as strongly named properties. And I can have the compiler warn me if I name them wrong, if I use the wrong names in my code. So by using a type provider, I'm able to transform unsafe dictionary lookup code into strongly typed property resolution code with only the addition of, I don't know, there's a few characters there, but I've not had to write out all of that wrapper code. The type provider has done it for me. The compiler is working on my behalf. It's helping me. It's saving me work. I love that. Does that all make sense to you? Can you see the use cases for that? Can you see how there's a few heads nodding, a few heads not so much? We good? Okay. All right, I'm going to kind of begin to move off a little bit from what we're seeing in current languages now into some stuff that's kind of a little bit more theoretical, a little bit more computer sciencey, but we're still talking about things that are kind of available now. So with type providers, we're moving into an area, or moving close to an area called dependent types. And the concept of dependent type is pretty much what it says on the tin. It's a type that depends on a value. So in a vector example, we could have a 2D vector, a 3D vector. The vector type depends on the value, the number of dimensions that are passed to it. Our regex type depended on the regex string. We've actually seen another example flying by, which is this stuff. Some of you may have been looking at that and going, so, printfun, that looks awfully like a C-style format string, Ivan. You've been trying to sell us this as a modern, type-safe, compiler is working on your behalf, everything is lovely, everything is type-checked language, and you're selling us C format strings. We're not buying this. Well, let's see. So suppose that I change this to %d. Now, in a C format string, that would be saying, well, I'm still passing a string in at the end here. C would be perfectly happy to accept that, and it will go, haha, at runtime, I shall interpret this string as a number, because that's what you've asked me to do, and I shall print it out as a number. And it will look like some horrible pointer value or some crazy thing like that. And it would not be good. In FSharp, you're actually seeing we get a compiler error because the compiler knows that the type of printfun with that format string is actually taking 2 strings and an int, not 3 strings. So it's a little bit like dependent type. There's actually some trickery going on in the compiler. But again, you've kind of got that concept of the type of printfun depends on the value that is passed into printfun. Does that make sense? We talked about, or sorry, Katie talked about type classes in the previous session. So I'm not going to spend too much time on these, but I just want to kind of briefly review these. So Katie talked about these in the context of monads as a Haskell type class. And as Katie suggested, type class is kind of a bit like an interface. So monad is not a class in itself. It's a capability that certain types have. And that sounds awfully like a Java or C# interface. Sadly for Java and C#, it's not possible to model these things as interfaces. But, let's... So, and again, I beg forgiveness from the Haskell programmers here. I'm about to do terrible violence to some of your standard library. But that was to avoid clashes when I was hoping to run this up. I'm not going to have time to run it, so there's no violence done. we can consider the example of structures where you can map a function over them, types that you can map a function over. So for example, if you imagine a list, you can map a function over a list. Each value in the list goes to another value, and you make a list of those new values, mapping the function over the list. You can imagine mapping a function over the maybe or option type, where the nothing or none maps to a none, and if you've got a value, the sum or just, then you map what's inside that and keep it as a sum or just. You can imagine a tree type where you've got branches, you've got leaves, and you've got values at the various nodes of those things. And you can imagine mapping a function over that, and the idea would be that it would preserve the tree structure, preserve the shape of the tree, but each value in it would be mapped using that function. You can imagine extending the option type to an error-prone type, which could include a message or other piece of information about the failure, rather than just saying, no value. And again, you can imagine mapping a function over one of those. If it's an error, it stays an error. If it's a success with the value, then the function gets applied to the value. So in Haskell, we can capture this with the idea of a type class. And Haskell actually calls this functor. I've called it mappable, I say, to avoid violence. And mappable just says, look, I've got to be able to do, I've got to be able to lift effectively a function from A to B. So I've got a function from A to B. I've got to be able to lift that to a function from maybe A to maybe B, or list A to list B, or error-prone A to error-prone B, or whatever. As Katie hinted, the value of this is that you can then program to these types in a unified way. If you know that something is a monad, there's a whole bunch of functions you can create just from knowing it's a monad. It's the same as with an interface. You know, if you've got an interface, you can write functions that use that interface. If you know that something is a monad, then you can write functions that use the monadic capabilities and nothing else, and you can get quite a lot of use out of that. Why is it not expressible as an interface? Well, I don't really have time to go into the details. The best way is to try and experience the pain and suffering. But basically what it comes down to is you want to write something like that. You want to write something like interface iMappable. It's got a map method. That map method has got to return something. And there's actually no way in CSharp or Java to express what is returned. But in Haskell, which has got a stronger type system, there is. And so you can have functors and monads and things in Haskell as a first-class idea much more readily than in C# or Java. Right, I want to round off with just mentioning a couple of things that are in the research community. Not going to have time to describe them much, but things that I think may come in handy. They may appear in languages in the near future. First one I want to mention is proof-carrying code. The motivation for this is mobile code. If you've got a container like a browser with a safety policy, you want to be able to run code within that safety policy. You want to check the code that you're running is safe. Who loves ActiveX controls? What, nobody loves ActiveX controls? That's better than usual. The reason that ActiveX controls suck and that native client, which is Google's sort of mobile code thing, is more successful is that ActiveX controls didn't really try to prove that anything complied to a safety policy. Native client goes through enormous lengths to prove that the code it executes conforms to the safety policy. But what if we had code, mobile code, that carried with it a proof that it conformed to the safety policy, so that the receiver didn't need to figure out the proof by itself. It could just check the proof that it was given. Checking a proof, following through those small verifiable steps, is much easier, much more mechanical than trying to prove it on this arbitrary blob. So proof-carrying code is going to be relevant to that mobile kind of scenario. Linear types and unique types, apparently they're different. I can't tell the difference between them. They're too brainy for me. The idea with these is constraining how often a type is used. So for example, imagine a pointer type. You want free, or the destructor, whatever your language calls it, you want that pointer to be freed once and once only. Not 0 times, not twice, once. And once it's been freed, not allowed to do anything with it. It's gone. You cannot use that reference anymore. You cannot use that pointer anymore. That is the promise of linear types, that they will manage that sort of numbering, that single use, that consumption for you. I think that many of us will never get the chance to work with a fully operational type system, something that combines the flexibility of dynamism, the expressiveness of dynamism, with the safety and capability of a full type system. And there's many other things that we could ask for that just aren't around at the moment, that I've not had time to cover. Things like structural typing is around in Scala, but don't have time to discuss that. Nevertheless, I think that we can look for ways to use our language that make more use of the type system. We can push our language designers, our language vendors, to give us these more expressive capabilities. Where we see great value in these capabilities, we can choose these languages because of interop on the JVM or the .NET or on the CLR. We can choose appropriate languages for appropriate parts of the project. We may not have the awesome power of a fully operational type system, but I think we can still be pretty goddamned awesome. Thank you very much for your time.